Today we're going to talk about Pascal's triangle, but before that, what is a binomial? Okay, I've given you 4 examples here. All these 4 are examples of binomials: x plus y, a plus b, and so on and so forth. Why they are binomials is because they have exactly 2 terms: x plus y, one term, a plus b, one term, 1 plus n, one term and one term. Alright, and these are examples of binomials. Alright, so now, okay, do not think that's just related to, we also can have 1 minus x, that's a binomial as well. Okay, negative 2 plus y, that's a binomial as well. So we can actually include, right, positive signs and negative signs as well in the 4 binomials. Now, let's start today with something simple. Let's do some binomial expansions. Alright, you may like to pause the video and try this out yourself to practice on algebra. Like 1 plus b squared. When we expand 1 plus b squared, what we get is a squared plus 2ab plus b squared. 1 plus b squared. Alright. Now, just for the sake of today, I write this 1 as well. Alright, it's a 1b squared. We normally don't write it. Okay, next one I want you to try is to do 1 plus b cubed. 1 plus b cubed is simply equals to 1 plus b times 1 plus b squared. And what we have here, 1 plus b squared, we have already done it above already, so let's not reinvent the wheel. So 1 plus b, alright, 1 plus 2b plus b squared. Alright, just go and do all the algebra, go and expand, and okay, go and do all your expansion and all. In the end, what you should get is 1, okay, plus 3b plus 3b squared plus 1 b cubed. There's a certain reason why I am putting it in orange for these coefficients, but we will explore that a little later. Okay, on your own now, why don't you just pause the video, alright, and try to see what you get when you expand 1 plus b to the power of 4. Okay, 1 plus b to the power of 4 is 1 plus b times 1 plus b to the power of 3. So we'll get 1 plus b times 1 plus 3b plus 3b squared plus b cubed. This is what we got, right, from the previous. Okay, if you notice, right, if you have expanded everything correctly, you should get 1 plus 4b plus 6b squared plus 4b cubed plus 1b to the power of 4. Right, now I want to show you a table I've drawn below. Okay, expansion of 1 plus b to the power of n. Let me explain that for a while. So when n is 0, 1 plus b to the power of 0, anything to the power of 0 is 1. Then let's say we have 1 plus b to the power of 1 is simply 1 plus 1b. 1 plus b square, in this case, is 1 plus 2b plus b square, as we have found out in the parts above there. 1 plus b cubed, 1 plus b to the power of 4, we have also done, and we have gotten this thing here. Now, I want you to notice something about this table, alright? Okay, for this table, as we are drawing, as we expand the different, for the different what I call powers, right down here, when n is 1, n is 2, n is 3, n is 4, and so on and so forth. Okay, like for example, 1 plus b to the power of 4, we get this whole term here. Notice the binomial coefficients there, okay? And we want to look at the pattern. So, here's 1, 1 and 1, 1, 2 and 1, 1, 3, 3, 1. I'm just copying out the coefficients. 1, 4, 6, 4, 1. Take a few moments now to think, how do I get the numbers, these coefficients there? For example, 1, Okay, how do you get this 2 here? How is the 2 related to the numbers above it? Alright, that's right. Okay, 1 plus 1 gives me 2. Okay, 1 plus 3 gives me 4. 3 plus 3 gives me 6, and so on and so forth. You might want to take a short moment now before to pause the video and to try to write out the next set of numbers, right, for 1 plus b to the power of 5 before I carry on. And it should be 1, 5, 10, 10, 5, 1. Okay, for power of 6 I get 1, 6, 15, 20, 15, 6, and 1. So you notice that there's a pattern there. This pattern over here, we call it Pascal's triangle, because this guy, right, called Pascal, Blaise Pascal, he was the one that actually discovered this pattern, and so we name it after him. So if I expanded 1 plus b to the power of 5, you notice that we have all these coefficients here. I can actually write 1 plus 5. Next thing that we should start to notice is what is happening to this b now. Notice that it always starts with b to the power of 0. Then here is b to the power of 0, b to the power of 1, b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 0, b to the power of 1, 2, 3. We can say that the powers of b are ascending. So here, if I combine Pascal's triangle with the expansion, notice that I'm not doing any expansion at all. I'm just using the pattern over here, and I notice that my powers of b are ascending. What I will have is 5b plus 10b square plus 10b cubed plus 5b to the power of 4 plus b to the power of 5. Again, pause the video and try, okay, using the pattern we have seen here to write the expansion of 1 plus b to the power of 6 without even expanding itself. You may like to pause the video now. Okay, now after you have tried already, what we have is this. And that is Pascal's how we use Pascal's triangle to help us in binomial expansion. Right, now next thing, right, I want to show you is this, right. Okay, if you notice something about it, alright, how do I get all these numbers now? Pascal's triangle can also be quite tedious to do. So one simple way, right, let's just look at this 1 plus b to the power of 6. Let's look at, right, all these coefficients there, and I'll just explain how they come about, so you can just make the link there. Notice this, I shall use the Casio calculator. Later I'll be fair, I'll use a sharp one. Okay, 6. Notice that at this point here, okay, for this one, it's actually 6 choose 0. Okay, I've just typed 6 choose 0. It is 1. This coefficient 6 is 6 choose 1. Is 6. This would be 6 choose 2. 6 choose 2 is 15. 6 choose 3 will be 20. 6 choose 4 is 15. 6 choose 5 for this term, it is 6. Notice that it's actually linked to what we learned in the previous video about the n choose r. Okay, let me give you another example from 1 plus b to the power of 4. First term is 4 choose 0. Okay, so 4 choose 0. Okay, you notice that for here, 4 choose 0 is indeed 1. Let's try for this term. It will be 4 choose 1. 4 choose 1. Indeed, it is 4. Okay, here is 4 choose 2. It is 6. This would be 4 choose 3. Is 4, and 4 choose 4 will be 1 by itself. So I have just made the link for you between Pascal's triangle and choose R and the expansion over here. Okay, and that concludes my video on Pascal's triangle. The next lesson we'll learn about using Pascal's triangle, right, and how we can derive the term for the binomial theorem.